Hi students, in this week's video, Practice Math with OLK, we're going to do Chapter 9, Applications of Straight Line Graphs. So do get some graph papers ready so that you can do along with me. Right, let's look at question 1. Question 1, we don't need graph paper. This is just a problem solving. You're given two variables x and y such that when 1 over y are plotted against 1 over x as straight lines obtained. So what it means is that on your usual x-axis, it's 1 over square root x. On your usual y-axis is 1 over y. And when such thing happen, you will get a straight line. We're not sure whether it's a positive gradient or negative gradient. So it can be in this direction or it can be the other direction. Okay, so basically this is what the information that you're given. And then you're given two sets of points. All right. So if you're given two sets of points, what kind of hints are that? Right, so let's begin by writing down the straight line equations, the formula, the general form, sorry, not formula, general form for straight line equations, which is, yes, so we're going to use uppercase Y, okay, so that you don't confuse, so that you do not confuse with all this variable. Okay, so we're going to use uppercase Y to represent y equals to m uppercase x plus c. So m will be the gradient of the straight line and c will be the y-intercept. Okay, so we are going to replace now your uppercase y is actually this guy here. This is your big Y. This is your big X. So we're going to replace them. All right. So you'll see that we actually have two unknowns there, M and C. So that is the reason why you're given two sets of data so that you can actually form two simultaneous equations. All right. So that's form the first one. Okay. So we're going to substitute both sets into the equation. And this you can easily use a calculator to evaluate. Okay, so don't bother yourself using manual calculation, just use a calculator. Likewise for this, just use a calculator and you end up getting 4 equals to n times 5 plus c. So we're going to call that equation 3. So using the second set of data given, we can form a second equation and we're going to solve them simultaneously. So we're going to take equation 3 minus 4. Right, so we get m equals to half. Right, so we can substitute m equals to half into equation 3 or 4 to find the unknown c. And then we're going to put both of these values back into our 1 over y equals to m bracket 1 over square root x plus c, okay, to form our straight line equation. And from there, to find the values of y when x equals to 9, just basically substitute x equals to 9 into it. Okay, and you'll get y equals to 3/5. Right, so the takeaway from this questions is the formations, okay, the formations of this straight line equation, understanding that the big Y in your y equals to mx plus c, it's 1 over y, and the big X is 1 over square root x. And then, of course, solving them simultaneously, right? All right, so the next question is graphical questions where you're required to do it on a graph paper. So you're given the table, all right, and also a equations. Right, so there is an error, okay, in recording one of the values of v, right, and you're asked to plot 1 over v against 1 over u. So in other words, your big Y is 1 over v, your big X is 1 over u. And when that happens, you actually get a straight line. All right, we're not too sure whether it's a positive or, oh, it is a positive gradient. How do you know it's a positive gradient? Because you can actually rewrite this equation in the form, we want to rewrite it in this form big Y equals to M big X plus C. So therefore, you can write it as 1 over V equals to negative 1 over U plus 1 over F. And then pull out the negative and if you do a comparison with what we have here, you can see that the big Y is 1 over V here, the big X is 1 over U here, and therefore your gradient is negative 1, right? And your 1 over F will be your C, which is your y-intercept. So therefore, this is a line with negative gradient, so it should go this way. Okay? Right. So therefore, we need to generate a new table. Okay, we can't use this old table. Right? Because we are plotting 1 over V against 1 over U. So we need a new table. So what is the new table that we need to have? Okay, as demonstrated, not demonstrated, as shown on the screen. Right, so to get 1 over V, basically you just get the calculator ready. Just take 1 divided by 1 over V is just 1 divided by 0.603, and you will get round up to 3 significant figure 1.66. So that explains this answer here. So you do the same for the next, for this value to get this, do the same for the rest. Okay, and then you will generate a new table because we need this new table to draw your straight line graph. Okay, in this questions here, the scale is not given, right? So choose the scale wisely. For example, what is suggested here is to choose 1 cm for 0.5 units. Do not choose 1 cm to be 0.8, 0.9, you know. It's very difficult to read. Okay, so choose one that is like, you know, like what I have here, 1 cm 0.5, because so every 1 cm is 0.5, so 2 cm will be 1 unit, and then 1.5, 0.5, 1, 1.5, you know, it's easier to read than 1.4, then what, 2.8, you know, yeah. And then just make sure that the graph is more than half a page, because if a graph is very small, then your accuracy will be compromised. So have it like at least half a page. Alright, so you can use the scale that is given there as suggested. Alright, okay. But bear in mind, in some exam questions, the scales is not given. So you need to have your own initiative to come up with a appropriate scale. Right, so this is how it looks like. Okay, if you plot the points accurately. Okay, accurately. And I need to mention that your straight line must pass through the 1 over B axis, must pass through your vertical axis. Okay, the straight line must be long enough to pass through your vertical axis. So if your straight line did not pass through the vertical axis, then you have to choose another scale. Okay, draw another, choose another scale such that your straight line can pass through the vertical axis. Okay, very important. And then from the graph, quite obvious, right, that this point here is out of space. Not out of space, sorry, out of the line. It does not lie on the line. So therefore, that particular value, if you were to go back to your original table, okay, go back to original table, is V equals to 1 over 3.80. Alright, it's 1 over V equals to 3.80. So you're finding V, right? So you need to have 1 over 3.80, 0.263. Okay, if we go back to the original table. So that will be the incorrect recording because it's not on the straight line. Alright, so how do we find the correct value for your 1 over V? So if you look at this point here, basically you just need to extend the line. Okay, extend. When your 1 over U is equals to 4, you draw this line longer, touch the straight line, then draw another horizontal line to touch the 1 over V. So that will be the correct value. which is 4.35. Okay, and then from there you just do a cross multiply. So 4.35v equals to 1, so v is 1 over 4.35. Just use your calculator to evaluate it, which is 0.230. So that should be the correct recording. Okay, so that's part 2. Then for part 3, okay, this is what I've done earlier on already, rewriting it in the form uppercase y equals to m uppercase x plus c. This is what I've explained earlier on already. Your gradient is -1, and your c will represent 1 over f. It's actually your y-intercept value. That's why I mentioned that the straight line must pass through your vertical axis. Okay, and then from the graph 1 over f, that value here, it's 8.3. Right, so the values of f will be 0.120. All right, so in the earlier slides also, I have shown you some the degree of accuracy. So if your answer is different from mine, you can refer to the earlier slides to check whether it is within the range. All right, so let's look at the next question. So this question, it's also a question that you need to get ready a graph paper, right? So we have a table shown to 3 significant figures, the populations of a country, okay, intervals in intervals of 5 years. All right, so if you look at the year, it's 1995, and then the next one jumps to 2000, because 1995 plus 5 will give you 2000, 2000 plus 5 will give you 2005, so on and so forth. Right, but we're not plotting the year against p. We're actually plotting ln p against x. Ln p against x. Okay, and then we asked to draw a straight line. All right, so the because if you don't have in these questions the grid line is actually provided. All right, the grid line is actually provided. So the scale is actually given in this question, which I'm going to show it to you later on in the next slide. You can follow the scale if you don't have the grid line. This part here is the one that I explained in the previous slide. If your answer, how do you check your answer is within range? Okay, so the accuracy is 0.05 unit on the vertical axis. In other words, whatever answers you get right, you just have to plus minus. You see your own answer plus minus 0.05, and for your y-intercept, and see if your answer is within this range. Okay. Right. Later I'll explain again. All right. Okay. So we need to generate a new table, right? A new table again. So basically, you just ln 3.32. Ln 3.32 will give you 1.20. Ln 3.75 will give you 1.32. Ln 4.24 gives you 1.44, so on and so forth. So on and so on, so on and so forth. So express your answer to 3 significant figure. The x will, of course, you leave it as 0, 1, 2, 3, 4. All right, so in the next part of the questions, we're asked to find the gradient of a straight line. So if you have drawn all your points, plot all your points accurately, you should get a beautiful straight line as shown on the screen. All right. Okay, we're asked to express p in the form a e to the power kx, where a and k are constants. Right. So of course this one is not a straight line. P equals to a e kx is not a straight line. Right. So we need to do something to it. And the hint given is that, you see, on the hint given, it's for your big Y is supposed to be ln P. So that gives you a hint that you need to bring natural log to both sides. So if you've forgotten all the rules, you know, you need to know the rules of the natural log, not just natural log, the 3 rules, like log bracket AB, that gives you log A plus log B, log m over n gives you log m minus log n, and log m to the power n gives you n log m. Okay, this one, just go and revise this if you have forgotten them. So we're going to bring a natural log to both sides. Alright, so to take note, one very common mistake students make is, now look that x belongs to the e only. Okay, take note, a e k x is not the same as bracket a e k whole thing to the power x. It's not the same. Okay, the kx only belongs to e. The kx only belongs to e. Alright, does not belong to a at all. So therefore, you cannot apply power law yet. You cannot apply power law here. You need to apply product law. Okay, apply product law. Alright, to get right. Then only then the next step, then you apply your power law to this guy here. And of course, ln e, it's log base e, so that gives you 1. They have a recap here, so I will need to erase this off so you can see better. Alright, so simplifying further, this is what you get. And then compare it with your, yes, the usual big Y equals to m big X plus C. That explain why, okay? This is ln P on your big Y, and this is your big X. Alright, so the gradient is actually your K value. Your K represent the gradient, which is you can find it, okay, by identifying 2 points on the straight line. Let me explain to you how I get this point here. Okay, I'm using this point because you have to use point that lies on the line. Points that lie on the line, you use that point. So I choose this point, and it's easy to calculate because if you look at my scale, the scale given to you, this is a scale given to you, so you have to use it. There are 5 square, 5, 10, 15, right? So 15 small square equals to 1 unit. So 1 small square is 1 over 15 unit, right? So if I'm talking about this point, there are 5 units here, right? No, sorry, 5 small square, right? So 5 small square will be 1 over 15 times 5, give you 1/3. So that explains this 1/3 here. Okay, and 1.24, of course, you have to read it off from your vertical axis. Okay, so 1.24, 1.212324. Okay, this value you have to read it from your vertical axis. So let me explain how you get this. So let's count the number of small square I have: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So that will be 55 times 1 over 15, 11 over 3. Okay, and then of course this value you have to read it off from the vertical axis. Of course, you don't have to use that 2 points that I use. You just choose any 2 points on the straight line. Remember, on the straight line. Of course, you're not going to choose this point here because this one does not lie on the straight line. Okay, you must choose points that lies on the straight line. Okay, so with that, you just use the formula to find gradient. Change in height over change in rise over run. Okay, and you'll get 0.123 for the values of K. Alright, now the next thing is that I need to find the values of I found K already, I need to find A, right? So let's go back to the original equation. This original equation. You see that when I substitute X to be 0, X 0, it starts from 1995, right? The values of P is 3.32. So we should be using this value, from the table. That is the most accurate one. The most accurate one. From the table, we have shown that when x is 0, p is 3.32. So you should be using the original data from the table and not from the graph, because your graph is not accurate. It's just that the table will give you the accurate one, the original one. That because that is when x is equal to 0. This question is different from other question. Okay, this questions, your original table actually give you the values when x is equal to 0. That means your vertical, your y-intercept value. Okay, the previous question, your y-intercept value, is not given in the table, so you need to use your graph to find. Okay, right. So from there, ln p is equals to ln a. Why ln p equals to ln a? Because you just substitute your x to be 0 here, so k times 0 is 0. So left only ln p equals to ln a, so p is equals to a, which from the table is 3.32, right? Then you substitute everything into, yes, the original equations, and that is how you find the answer. Okay, let me repeat this part. Some of you may be confused why I never get it from the graph. It's because on original table, you have your y-intercept value there already, so you should be using it. Okay, but in the second questions, you don't have it, so that's why you must get it from the graph. Most of the time, you get it from the graph. This question is just different. Okay, so the last part of the question is that if the model of population remains valid, find the year of the interval in which the population first exceeds 8 million. Right, that means the values of p is more than 8. So we're just going to let it equals to 8 and see what happens. Alright, so we need to divide 3.32 first on both sides. You don't bring ln yet, okay? You can only bring ln when you just have e. When you just have e equals to something, then you bring ln to both sides. So this step here is very important because a lot of students also make mistake here. You need to divide by 3.32 on both sides first. Yes, to have just e to the power of something only. Then you can ln it, and then you can apply the power law. Okay, ln e is equals to 1. Okay, and then you can calculate your x, which is 7.15. So 7.15 is still not even 8 million, right? So you should be substituting p equals to 9 to verify. So if you sub p equals to 9, right, verify to get x is more than 8. Okay, I miss out this step. You should also do that to make sure that when p equals to 9, I just assume that p is equals to 9. Alright, but sorry, I just assume that take x equals to 8. They're wrong. So you should let x equals to 8. Okay, after getting x is approximately 7.15, right, we should let x equals to 8 and see if our population is alright. So we will get 8.88 millions. So that satisfies this condition, exit 8 million. Right, so therefore we need to substitute x equals to 8. Okay, so we have to show this part here to verify. Okay, to confirm when x is equals to 8, the population exceeds 8 million. Right, but remember your values of x is intervals of 5 years. Intervals of 5 years, right? So what you need to do is you need to take x times 5, then add to your first year, which is 1995. Okay, and that gives you 2035. So in the year 2035, your populations will first exit 8 million. Alright, so if you want more examples, do refer to the earlier video. Okay, I have an earlier video. I'll put the link, okay, in this video so that you can refer to it if you want more practice.